Welcome back to Aurora Tech Channel. Today, I will review the GENMITSU 3030 Pro Desktop CNC. The machine is $849, so let's take a look at what we can get from it. As its name suggests, the working area is 300 by 300 millimeters, and the Z travel is 78 millimeters. The motion system uses double linear rails and ball screws on the X, Y, and Z axis. The bed is made of one-piece solid aluminum instead of being formed by a few aluminum extrusions or MDF hybrid beds put together by screws. It also has dual limit switches installed at both ends on all axes. The machine weighs over 50 pounds, and for a machine of this size, that's pretty heavy. The stepper motors are 48mm higher torque NEMA 17, and the controller box has its own metal housing and is right next to the machine. It comes with a 3-inch color screen, which also works as an offline controller, meaning you don't need to connect a USB cable to your computer and run another G-code sender software to control the machine via the virtual serial port. There's an emergency stop on the screen, and it also has a tool height setting Z probe that connects to the screen. The spindle is a 300-watt air-cooled spindle with a maximum RPM of 12,000. It also comes with a 65mm router mount for you to use your own wood router like the Makita router. I will also use that to cut aluminum and compare the result with the stock 300-watt spindle. There are extension ports for you to connect to 4-axis, which I will also test out. It also has a port for you to connect a MPG hand wheel, and it is compatible with the laser engraving module. For other accessories, it includes an air tube, which you connect to your air compressor or mist cooling system, and there's also some basic clamping tools and engraving bits. The machine is mostly assembled, so you can expect to spend less than 50 minutes on assembly, and it should work right out of the box. I would like to thank GENMITSU for sending us this machine to review, and with that, let's get started. This 52-pound machine is close to 60 pounds with packaging. It's well protected by a few layers of thick laser-cut foam. The gantry is on the top layer, and the one-piece base is at the bottom. We have the gantry, the base, the controller box, a 300-watt spindle, some cables, the air tube for connecting a compressor, and 2 mounts, one for the stock 52mm spindle and one for 65mm wood routers. There's also the user manual, a box of 10 engraving bits, a color screen, and a box with all the tools and screws you need to put this machine together. We will start by securing the gantry to the base with screws. Connect the color screen at the front right, connect the cable from the base to the back, put on the spindle mount, then the spindle, and connect the spindle power. Finally, connect the controller box to the cable hub at the back of the machine and the power cord. Now the machine is ready to use. The color screen is not a touchscreen, and it's controlled by the knob. I will use it to jog the machine and test the spindle. Home the machine, and all the axes, the spindle, and the limit switches are working. Let's start with some soft materials. I will use the engraving bits that came with the machine to engrave a Gryffindor logo on a piece of 1/2-inch thick red oak wood. I will do a 1mm step down and 2 passes. Then, I will switch to an 1/8-inch 2-flute flat end mill to run a contour with a 1mm step down and 14 passes to cut it out completely. I will use the Z probe to set the tool height. For a flat end mill, you can just let it do its job, but for an engraving bit as it's sharp, it will poke the probe's surface and lift it up. So, it will be better to apply some force to make sure the probe stays in its place. After the engraving is done, I will change to the flat end mill and set the tool height again. I didn't use the clamping tool that came with the machine and used my own mini vise instead. As you can see, it will just drop right off after it is completely cut through. The engraving result is very nice. The 300-watt spindle isn't very powerful, but it's good enough for this red oak wood. The cut is also fairly clean. It will look even better with some light sanding. Next, I will cut a ninja star from a 3mm black acrylic. I will just run a simple contour and cut 4 passes. This time, I put a spoil board underneath to protect the aluminum bed. As the acrylic is quite large, I didn't cut it down to a smaller size and just tried to mount 3 corners to secure it. I didn't mount it too well, as you can see it flexes a little with the cutter plunged down, but I will just let it finish, as this shouldn't have too much of an impact on a soft material like acrylic. It cut through completely after 3 passes, so I stopped the machine manually. Even though the acrylic is not mounted perfectly flat, the cut still looks clean. On one of the edges where the stock was vibrating, the cut isn't that clean, but the rest looks alright. Then, I will try some aluminum. First, I will start with a 300-watt stock spindle. I will make 10 slots on this 1/8" 6061 aluminum plate. I will use a 200mm feed rate and a 0.1mm step down all the way to a 1mm step down. As you can see, this slot operation in Fusion 360 will generate a progressive step down. For example, the last slot step down was set to 1mm, but it won't plunge all the way down 1mm, but it'll move back and forth to reach that depth progressively. This would make it easier for smaller machines. I will switch back to my mini vise and set the tool head again. The sound is a bit high, and you can hear some vibrations, as this kind of air-cooling 300-watt spindle is not that powerful, but let's see how it works. Now cutting the last one, the chip size is larger, but the sound is also louder. I can hear that the spindle is reaching its limit and the cut is not that smooth. Okay, it finally finished without breaking anything. Let's take a look at the result. The first one at a 0.1mm step down looks cleaner than the last one, but all of them are not very clean. It can still cut aluminum with a fairly acceptable result. Then I will make 2 pockets. The size is 20mm, the depth is 2.5mm with a 0.3175mm step down. For pocket operation, it will plunge all the way down to 0.3175mm. The circle would be the same 2.5mm and 0.3175mm step down as well. As you can see, the chip size of the 0.3175mm step down is larger than those made with the slot operation. Okay, the result is not too bad. The edges look slightly cleaner than the slots, and the circle is a little better. Let's check the accuracy. As the edges are not smooth, we can expect the square to be larger than the original size. It's 20.17mm instead of 20mm. The circle is slightly better, but the widest point I can measure is still a bit off at 20.14mm. As the machine is rigid, if we switch to a more powerful Makita router, I expect the result could improve tremendously. It sounds much better. I can't hear the vibration anymore, the cut looks much cleaner. I will let it run the exact same G-code and see the result. I think the result is much better. All of them look smooth, even the last one with the progressive 1mm maximum step down. When compared to the one on top, made by the 300-watt spindle, the difference is obvious. Let's also make 2 pockets and compare the result. This time the square measured to be 19.97 millimeters, which is pretty close to 20 millimeters. And the circle is 19.96, so the accuracy of about 0.04 millimeters is pretty good for a desktop machine. When putting them together, the 300-watt spindle can mill aluminum with some rough finish. The machine is rigid, and the bottleneck is the stock 300-watt spindle. When using the Makita router, it not only gets almost mirror finish, but also has high accuracy. As this machine also has an optional 4-axis roller, I will try it out. I will make a queen chess piece with a red oak cylinder. The first operation will be roughing. I will use the same 2-flute 1/8-inch flat end mill with a 2mm step over and a 1mm step down, leaving 0.5mm stock. Then I will use a 1mm ball end mill for finishing using a 0.2mm step over. On my first try, I found that the 4th axis is moving super slow, so I modified the firmware parameters to double the speed and acceleration limit to 1000 mm per minute and 15 mm per second squared and tried again. As you can see, the machine y-axis is moving along with the 4-axis roller. So this is a real 4-axis machine instead of using the roller to replace the y-axis like a laser engraver. The roughing operation finishes in 1 hour and 10 minutes. Then we will start the finishing operation with the 1mm ball end mill. It took another hour to finish. Making a chess piece like this requires a little over 2 hours, but the result looks good. After cutting off the bottom with a miter saw, this queen looks pretty awesome. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. This machine requires minimal assembly. It's even easier than putting a 3D printer together. You can start using it in 15 minutes, and it works pretty well right out of the box. 2. The whole machine is rigid. It's smaller than other GENMITSU machines I've tested, but it's equipped with all linear rails and ball screws on all axes, so it's just as rigid as those larger machines, and I can cut metal as aggressively and quickly as I did on the 6050. 3. The solid aluminum bed is high quality. As it's one piece, it's more stable than those formed by a few aluminum extrusions or a hybrid joined together using screws. 4. The offline controller is handy. Even though it's not a touchscreen, I still use it to do all the jobs in this video. Personally, I don't like using Candle or the universal G-code sender, as when you use the USB cable to connect to the PC and use the virtual serial port, it may occasionally show errors, especially if you run a job that takes over an hour. However, with this offline controller, I didn't see a single error during the whole testing process, but I will talk more about the screen later. 5. It also included the mount for 65mm wood routers. The stock setup came with a 300-watt basic spindle, and it works fine with soft materials like wood and acrylic. It can also cut aluminum at a slower speed with acceptable results. But of course, if you need to cut metal faster and with better accuracy, spending another $140 for a Makita router would be the better option. Now for the cons. 1. The color screen just uses a knob instead of being a touch screen. When jogging the machine in all 3 axes, it would be better to use the touchscreen interface with arrows. It also doesn't let you adjust the speed after the job starts. For example, with the queen chess piece, the G-code was supposed to finish in around 1.5 hours, but I set the speed too slow and it actually took almost 3 hours. If it allowed speed changes on the screen, I could have just sped it up to 150% or even 200% as long as I could see that the machine can handle it. 2. The X-axis is well protected, but the Y-axis isn't, and the Z-axis is entirely unprotected. I understand that the Z-axis of a small machine is limited, and it may decrease the usable Z height if you add bellows, but at least for the Y-axis, I would like to see better protection. 3. The clamping tools are the most basic ones you find on an entry-level 3018 CNC. For the price of this machine, it deserves something better. As a result, you can see I just use my own mini vise, and I'm just not a big fan of those cheap clamps. 4. The aluminum bed is nice. It would be better if it came with some thin MDF spoil boards with matching screw holes, as you may make mistakes and cut the bed sooner or later. If so, I believe it wouldn't be cheap to have it replaced. 5. The maximum 78mm Z travel is alright if you're not planning to use the 4th axis. However, as the center point of the 4th axis is 50mm, it's only 28mm away from triggering the top limit switch. When including the 5 to 10mm retraction height, you can see there's not much room left when I was making the queen with a 25mm flute length tool to avoid collision. In conclusion, the build quality of this GENMITSU 3030 Pro is high. The machine has all linear rails and ball screws, so it's just as rigid as larger machines like the 6050 and 4030 V2, except with a smaller footprint and lower price. The assembly is easy, so it's also beginner-friendly. If you don't need a very large working area, this can be a capable desktop CNC that lets you work with wood, acrylic, other soft materials, and even metals. The machine is around $850, and even with the Makita router, it'll still be under $1,000, but that's not including the $249 4-axis and the mini vise you saw in this video. If you're interested in the CNC 3030 Pro, I've included its link as well as the link to my website, auroratechchannel.com, where you can find my recommendation list and a price tracker that monitors 150 popular 3D printers, laser engravers, and CNC machines, all updated hourly. All relevant links are in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.